Hello, everyone. How's everybody doing? I hope everybody's doing fine. Before I forget, I just want to mention that we have a conference coming up for us, Sweden, and here's the information so far. It's going to be June 8th, okay, in a little town there called Boris. And Saturday, it's probably going to be part in the morning and the afternoon. And we're still setting these things up, but no biggie. We always get them done sooner or later. And I'll be there. I'm going to be presenting something related to physics, specifically what is a physical interpretation. I'm going to be dealing with that subject, and you're going to meet some very interesting people that usually show up. And you want to test your theories. Those are the right people to encounter, to have them challenge your theories. Okay, today I was going to talk about continuing to talk about um, ether, space, empty space, uh, which is nothingness, right? Nothing, and infinity. But I'm going to make a little detour. I'll make a little detour because some people put some comments, some of the videos, and I think some of those are worthy of being addressed. And so I'd like to address them here today before we continue because there are some misconceptions out there, specifically what this site is about, what the rational scientific method is about, or rational science. Now, you don't have to agree. All I'm saying is, you may be in the wrong place. You may have your ideas. You come here, you say, oh, this is just standard science. And here you'll find a total paradigm shift. Uh, we got a new scientific method. That's why we call it rational scientific method. You say, why the word rational? Well, the word rational is there because what they're doing today is irrational. Okay, in our opinion, our humble opinion. We have black holes, dark matter. We have creationist Big Bang, taken right out of the Bible. Without God, they forgot God, they left him behind. Fine, but we think all those are irrational theories. Uh, Particles are zero-dimensional. They're actually the vibration of a field. The word field is undefined. Matter comes in from the void, from the true void. No, it comes from energy, which is sizzling over there in the void. All this nonsense that we find from both quantum mechanics and general relativity. And so as a result of that, we had to come up with an alternative, and that's the rational scientific method. And that's in opposition to what we see today. Anyways, I start my chat with a little comment that someone placed and in one of the videos, and that's a good place to start. Here it goes. This gentleman, I think it was a gentleman, writes, a long time ago in a galaxy far, far away, there lived two tribes on adjacent planets, the rational sciencers and the get on with it ers. Okay? On the planet of the get on with it, the big news of the day was the scheduled launch of the first space vessel aimed at a neighboring star. On the planet of the rational sciencers, the big news of the day was the continuation of the 10,000-year-old daily debate of what is an object. Sounds nice. I kind of like that, punch in the nose. Okay. Guy said a mouthful. And yeah, I was very happy when I discovered the rope model of light. But I think more fundamentals, what I developed over the course of the next few years, like 10 years later, um, discovering what the foundations of physics are and zeroing specifically on the fact that in physics, you need an object. You can't do physics without an object. And so, yeah, he's saying that that we have a 10,000-year-old debate. Well, really, not so. In rational science, we have already settled that an object is that which has shape. So there's no issue there. It's the people whose religion that definition destroys that have a problem. And of course, they can't come up with an alternative definition. And this is where the problem is. It's their religion that is shaky. And among part of that religion is what this individual is saying. That he's saying that somehow, what did he say here? He says that we're going to go to another star system, the launch of the first space vessel aimed at a neighboring star. You know, it's never going to happen. Never. It has no chance whatsoever of happening. And part of the reason for that, ultimately, is because he did not define what an object is. It comes down to physics, the fact that physics requires objects, and that you have to define what an object is for the purposes of physics. Okay, so where do we start? We start at science. What is science about? What is physics about? That's the place where we have to start. And people say, well, we've already covered that, 400 years ago. We know what science is. We know what physics is all about. And then again, they talk about math, and they talk about making predictions and about verifying and falsifying, which we say has nothing, absolutely nothing to do with science. So no, that matter is not settled. We need to figure out what science is. We need to define science in a way that we can use the term consistently, and we can say this is science and that's something else. Okay? And so here I have a little diagram that gives you a little a vision of a snapshot of what science is about. And we're saying something totally radical. We're saying that science is about rational explanations. It's the collection of rational explanations that we've always had. Anything which is irrational does not belong to science. And science is divided into branches, physics and philosophy. Physics, the one we're concerned really about, deals with objects, causes, and mechanisms. And it's an objective thing. You have to be able to explain it objectively. Okay, so you do need objects. You need to explain causes, and you need to explain mechanisms. That's what we're saying that physics is about. And again, we go back to the definition of science: rational explanations. There's no provision in there for mathematics. There's no provision in there for persuading, convincing, for presenting evidence, for proving, for verifying. None of that belongs to science. And experiments, we don't run experiments in science. It's about explaining rationally. And of course, this offends a lot of people because a lot of people come from high school and college and they've been drilled to exhaustion that you can't do science without math. You can't do science without presenting evidence and verifying your theory and this kind of thing. And we're saying none of that has anything to do with science. Okay, so it's important to know that. So whatever is not a rational explanation belongs to religion. Religion has typically irrational explanations, but religion is really something else. It's not a belief in God. Religion is opinion. That's what religion is. If you have opinions, you are doing religion. You're doing your personal religion. So we don't care about your opinions or your beliefs. What we care about is a rational explanation, a rational mechanism that you can explain of how Mother Nature does something. Magnetism, light, gravity, whatever. It doesn't matter. But we need an explanation. So we don't care if you believe in it, if you got all the math to prove it, and that you convinced all the mathematicians on Earth of your theory. We don't care about any of that. Physics is only a rational explanation. If it's not rational, it doesn't belong in physics or in science for that matter. Under irrational theories, you will note that we put atheism and agnosticism. atheism, agnosticism, just like theism, all three belong in religion. And of course, I'm going to justify that as well. But it's got to do with, again, what you see there in science underneath rational explanations. We're going to use that definition until it hurts, and we're going to use it consistently. The only way to use that definition consistently is not to, deviate one iota from any of those letters. And that's where atheism, agnosticism, and theism, all three, go on tangents that have nothing to do with rational explanations. Okay, so where do we go from here? Well, um, if um, if science is about explaining rationally, you might have the question, well, what do you mean by rational? I mean, that's your opinion. We have good theories, bad theories, correct theories, incorrect theories, true theories, false theories, wrong theories, right theories. And you say rational theories and incorrect theories belongs in that group. Those just opinions. And the answer is no. No. We don't, all those, the first ones that I mentioned, those are all opinions. Rational is not an opinion. We have objective criteria for what is rational and what is irrational. And that's why we can use that word consistently, because we took the trouble of defining the criteria that's going to define, what rational explanations are. What is a rational explanation? Okay, so let's look at that. Rational explanation. What do we mean by rational? Well, it's better to focus on the word irrational. What is an irrational explanation? Well, the main one is the first one, converting a concept into an object and to pretend to move it around. That's what it is. If you move love around, then you're doing religion. You're doing some irrationality. And you might say, well, I was just kidding. I was speaking in tongues. I didn't really mean it. I was using a metaphor. I was using poetry. Physics is literal. You can't move a concept around. You can't say that you warped time, especially with gravity, another concept. You can't say that you moved a mass. You can't say that you transferred energy or transferred information. Those are irrational statements. You can use them maybe to do your closing arguments after you explained your theory and you want to use a little poetry in there, no problem. But the main body of your theory, you better not say that you transferred energy or that you waved the wave or that you, moved love or whatever. You can't use concepts. Second one, you must define words very precisely and you have to use them consistently. What does consistent mean? Rationally, scientifically. That's what consistently means. That's why a scientific definition differs from what we have in ordinary speech. People get in the habit of introducing ordinary speech into science and they think they can get away with it. They don't realize what they're doing. They cannot introduce the words of ordinary speech directly into science, especially the key words. Okay, and we don't need to define every word in the dictionary, no, and that's a long story. But the point is, you need to define the words that make or break your theory. Okay. Third one, theory has to follow from the assumptions. Okay, so you have like the initial scene of the crime, and you have a dead man on the floor and he's got a knife stuck to his back, and that's your initial scene. And so your theory is going to be something like, someone stabbed him, right? And instead you tell the jury, well, the man drank poison or he was shot to death. What do you mean shot to death? What do you mean he drank poison? I thought what you presented in your hypothesis, in your initial scene, was the fact that he had a knife stuck to his back. What does that have to do with bullets and poison? So the theory has to follow from your initial assumptions, or from what I call the initial scene, or what I also call the statement of the facts. Statement of the facts is not the same thing as the facts. The facts is what Mother Nature knows. She knows exactly what happened, We can only go back and say, this is what I think happened. And from there, you have to start from an initial scene. We call that the statement of the facts, your statement of the facts. We need to be able to follow your presentation, your theory, your explanation has to follow from that initial scene that you presented. Okay. And then the last one there, oh no, I missed one there, sorry. When you describe, like, for example, mathematically, and you claim to have explained, and you'll find lots of people on the internet who say, oh, I can tell you how a magnet works. And they never do. They describe and they claim to have explained. And it doesn't work that way. I'll give you, for instance, the most common is that people will say, look, how does a magnet attract another? And the guy will go out there and say, oh, I know exactly. I can tell you exactly how it happens. And the way it happens is you have the electrons in the atoms over here in this magnet pulling in the same direction as the electrons in this other magnet. And that's not an explanation. That's a description. All you've done is tell me that when a magnet attracts another, you discovered or you measured or somehow you determined that the electrons over here spin in the same direction as that over there. You still haven't explained the mechanism. I mean, is this electron somehow tied to that other electron, reels it in? I mean, what is the mechanism? I need the physical mechanism. To say that the electrons over here turn and this turns in the same direction when two magnets attract, that's just a description. And it has nothing to do whatsoever with explaining. Okay? So just keep that in mind. And there was one more, and that's the last one here. And that's that when you mix philosophy with physics, and including the introduction of observers, testimony, and belief, some people say, why is there something rather than nothing? And that's a question of reasons and purpose introduced in lieu or in the guise of causes and mechanisms. So that is an irrational question. Another irrational question that goes to atheism, and I'm not going to go into that in a lot of detail, but I don't believe that God exists. That's an irrational statement. It's an irrational statement because God can never be a theory. You can believe in a theory. You can believe that God created the universe or that God did not create the universe because you're talking about a mechanism. You say, how did the world or the universe come into being? You say, well, God waved his magic wand and said abracadabra and made the universe. Okay, so you explained a mechanism or attempted to. And some people believe in it, some people don't believe in that, right? But you can't say that you believe that God exists. Existence is not an issue of belief. You don't believe or disbelieve that this chair exists. Okay? And so atheists get upset when I tell them this. And by the way, I've been an atheist for most of my life, so I've been there, done that. Okay, until I discovered the scientific method and found out that atheism is nonsense too. And it's nonsense because an atheist doesn't realize that he's violating science. Science does not say that that you believe in God, in the existence of God, or that you don't believe in the existence of God. That's belief. And in science, we say something different. In science, we say, let us assume that God exists. And now I'll explain my theory based on that assumption. That's how science works. Science doesn't say, I believe in God and you're wrong. And I've proven that God doesn't exist or that he exists or whatever. That's not science. That's religion. That's why these people have been arguing in circles so many years, atheists and theists and agnostics. Science, we don't say, I believe, I know, I don't know. None of that has anything to do with science. That's only trying to shove your religion down my throat. The way it works in science, let us assume God exists. And I can say, let us assume there is a chair. Does it mean you're going to believe in the chair that I just imagined for you? No. In the existence of the chair. No, you don't believe in existence. Existence is always part of a hypothesis of your assumptions. Never, never, never part of a theory. Okay? Okay, so continuing here. Um, what does that take us? It takes us to the rational scientific method. Okay. What is the method? Now we're talking about the method. Okay. We're going to be doing science and we have to have a way of presenting a theory to someone so that he can follow us. He can follow our presentation. He can get an idea of what your mechanism, what that you're proposing is. Okay. And we have three steps. The first one is hypothesis or assumptions, and that includes three elements. The first one is you have to identify the objects. And again, we're talking for the purposes of physics, not of philosophy. Okay. You have to identify the objects. I need to know what objects are going to be the main actors in your physical theory. That's the first step. Second step, you have to define the key words that are going to make or break your theory. I need to know what you mean when you say the word object, especially. That word is very key because if you think that an object is that thing that you can touch or see, well, obviously you've got an erroneous definition. And that definition has to be criticized before you can even begin to tell us your theory. We have a problem with see, touch. We have a problem with volume, mass. We have a problem with that which can move. All those definitions are irrational. Uh, um, they don't qualify as definition for the purposes of physics. Okay. Then you have to describe the initial scene, or again, what I said earlier, the statement of the facts. You have to present the initial scene so the guy knows where in the film clip he's got to start to understand that piece of mechanism that you're going to explain. Okay? Then step two, theory, it's an explanation, and the only thing I'm going to clarify that for now so that we don't get extended on this, an explanation is not a description. Mathematics only has the ability to describe. Mathematics has no ability whatsoever to explain anything. Therefore, mathematics is not a part of science. And you say, Bill, are you crazy? I mean, you come out of high school and college and they say, mathematics, and we ran this experiment and we sent rockets to the moon, and that's why GPS works and why you have a computer, because if it weren't for quantum mechanics, your computer wouldn't work. They get all these cliches that they throw at you. None of that is science. None of that qualifies as science. Why? It has to do with the definition. You got to stick to the definition once you define it. Every letter in that definition counts. What is the definition of science? Rational explanations, right? So why would I introduce mathematics to explain something to you? Do I need mathematics to explain something to you? And here, let me show you a for instance so that you can follow my train of thought. Where is it here? I want you to look at this. Very simple thing. You see the guy, and he's using a pulley, and he's pulling a box. Okay? Do I need any math to explain how the box went up? I just want to explain to you how the box went up. That's all I want to explain to you. And all I have to say is, look, I tied a rope to the box. The rope went around the pulley, and I pulled on the pulley. I pulled on the rope through the pulley and pulled the box up. That's how the box went up. Did I use any math to explain all that? I just wanted to explain how the box went up. That's it. Do I need any mathematics to do that? In fact, I don't even need any language. I can just show you the movie. And you watch the movie and you say, okay, I know how the box went up. You understand just by watching the pictures, the movie. That's how you understand it. Let me give you another for instance here. See if I can get it here. Where is it? Here it is. Tell me how the window broke. Here it goes. You didn't see it? Okay, let's go slowly. Now it goes slowly, and you'll see how the window broke. Got it? Okay. Do you need more time to figure out how the window broke? Do you need any math? Do I need to run the test again to make sure we understand how the window broke? Do I need to present evidence to convince you how the window broke? No, you just watch the movie and you say, I know how the window broke. The ball hit the window and broke it. Okay, and that's one theory. Another guy might say, well, no, it was a baseball bat or crowbar or Johnny's baseball or whatever. All you have to do is watch a movie and say, okay, I see how the window broke. Doesn't mean you're going to believe that's how the window broke. Evidence would be there to present. It's what a prosecutor presents to persuade you, to convince you, to recruit you into his religion. So let me tell you how the window broke so that you can vote for my case, side of the case, not a defense. You don't vote for them, you vote for me. And this is how it broke. It broke this way. All he's doing is trying to twist your arm to believe, to vote for his side of the case. That's all he's doing. In science, we don't do that. Science, we just explain. Look, this is how I believe the window broke. This is the mechanism I propose. A ball went up, hit the window, and broke it. That's it. That's my theory. Okay, the other guy comes over and he says, no, I have a different theory. I say that your neighbor, he hates you, and you came in with a crowbar and just broke the window. That's a different theory. Okay? Another guy says, no, a dog jumped through the window. They have all these different theories. Okay? You can believe the one you want, but we need the mechanism. How did the window break? You don't need any math for that. And this is the issue. The issue is that we need to explain mechanisms, and people get sidetracked with, oh, you need math. Oh, I need to verify. I need evidence. I need to run an experiment. Not at all. All you need to do is listen to the different theories. And if they're physical, I show you my movie, this guy shows you his movie, the other guy shows you his movie, and now you have all these different movies, all these different theories, all these different explanations of how the window broke. That's the way it works, okay? And we don't have that today. And here you get a reason why. For example, we can figure out stuff like what you just saw. You saw the window break and you saw a guy pulling on the box, right? You say, okay, that's easy. Kindergarten stuff. I just watch and say, okay, I know how he did that. The guy pulled on the rope and pulled the box up. And how did the other guy do? Well, the other guy just threw a ball and broke the window. It's easy. It's a no-brainer because it's kindergarten stuff. And that's what physics is all about. Physics is about kindergarten stuff. Okay? You need to go to college to learn math. I mean, I've taken my damn share of mathematical courses, hundreds of. I really took a lot of math, but that's got nothing to do with what I'm talking about. When you go to the university, you need to do a lot of studying to learn math, okay? To learn it well and really understand it. You don't need math to understand this stuff. This stuff is kindergarten stuff. This is stuff that any kindergartner understands. You say, how did the window break? Oh, I know. Yeah, a ball hit the window. Okay, and you know. And the kid knows. He just watches and knows how the window broke. So that's the issue. So what's the problem? The problem today is that people cannot, you can explain what you can see. But what happens when you cannot see? What happens when you cannot see the mediator? That's where it gets tricky. And here you have a case. I love this one. Here it goes. Here you have a magnet underwater. Okay, the magnet is underwater. And you can see it pulls one iron filing at a time. It's not, when we put a magnet like on a piece of paper, all the iron filings immediately go around it, and so nobody sees what's really happening there. And what's happening there, you can see very clearly. In water, the magnet pulls one at a time. What does that mean? It means something is moving in there. This so-called magnetic field is something in motion. It's something in motion that affects matter. Okay? And that's very difficult for people to understand because they say, well, I don't see anything. I can't feel anything between the magnet. I put my finger in there and there's nothing there. But you can see that the iron filing detects something there, or better yet, in reverse. There's something there that's moving, because you can see it's pulling one at a time. Something is moving and pulling one iron filing at a time. Get that through your thick skulls. You need to answer, what does Mother Nature use that is moving, that is pulling one iron filing at a time? And so this is a very important case where you have something invisible, ghosts, spirits, acting in there and between the magnets, and they're affecting matter. And I want you to know, James Maxwell, 19th century mathematician, you could call him mathematical physicist, and even before him, Faraday, Michael Faraday. They did Faraday did a lot of experiments with magnets, and Maxwell, he wrote a lot of math, did a lot of calculations, came up with equations. They both of them believed, and in fact, Maxwell says, in that region field, in that magnetic field, there is matter in motion. Matter in motion. Matter in motion. Of course, it's some kind of exotic matter. He did not know what it was, but he said there's matter in motion in there. And Faraday said, I cannot conceive of lines of force without some physicality, some matter moving in there. So they both concluded the same thing. They did, they were very familiar with magnetism. They were not idiots in that sense, right? But they both concluded that there's something in motion in there. Well, today people have no idea whatsoever. They say, oh yeah, a magnetic field. Magnetic field is a concept. You don't do physics with concepts. That's what just showed. You do them with objects. And so, you need to do it with objects. You need to identify those invisible mediators. That's what. See, with the pulley, we said, oh, okay, I see the mediator. The mediator is the rope. How did the window break? Well, I know the mediator. The mediator was the ball. So you have no problem with the mediators because you can see them. You can see them on the screen. Well, what if we were to put the invisible mediator of a magnetic field? What if we made it visible? What if we made it visible? Well, that would be my theory, and someone else would put something else in there. Someone would put particles in there. Someone would put maybe waves, or maybe ether, or whatever. And I'm going to put threads in there. Those who are familiar with the mechanism of attraction between two magnets that I propose, I put threads. And so we have different theories, different explanations for that phenomenon. And you can choose the one you want. Everybody's got his own religion. And you might say, well, I like particles. Fine. Okay, so you believe in particles. I'm just saying that you need to explain it with a physical mediator. You got to show us what the mediator is. Okay? Otherwise, you don't have a physical theory. You can't say, well, mass does it. Gravity does it. Oh, the magnetic field does it. No, those are not physical mediators. You got to put a mediator. You can put a dog in there. You can put a chain. You can put a ball if you want. I don't care. But put a physical entity between those two damn magnets. Otherwise, you don't have a physical theory. Okay? So that's what this site is about. Whether you agree with that or not is a separate issue. I'm just saying this is what this site is about. Okay, and here's another one. I created this little thing. And here you'll see the little boy, and he's going to kick the bottle, and it falls to the floor. Well, we call it gravity. Well, how come it went to the floor? Why didn't it go, why doesn't it go to the ceiling? Why don't the bowl of cereal just fall to the ceiling? Right? Never happens, right? I mean, unless you're in the Twilight Zone or something, usually, things fall to the floor. And the question is, how are you going to explain it? You need to put a physical mediator between the floor and the bowl, or the milk, or the bottle, or the spoon. There's got to be a physical mediator touching the skin of those different objects. Something is coming in contact with the skin of the bowl, with the skin of each cereal that you have in the bowl. And you have to identify that object. You have to make it visible. How do they explain it in so-called science today and so-called physics or mathematical physics? Well, they explain it with particles, or they explain it with the famous um, fishnet canvas of general relativity. And a lot of people, are not aware that general relativity is a cosmic theory. You can't do you can't do general relativity here on Earth. You got one nut in the internet on YouTube says, "Oh, I'm going to do general relativity. I'm going to do space warpage here in my basement." Einstein would laugh at him. I mean, he's misrepresenting poor old Einstein here. Einstein's theory does not work at the Earth level, okay? It only works out there for a cosmic, long distance phenomena. It doesn't work here on Earth. Here on Earth, unfortunately, you got to use quantum. And people are not aware of that. They say, oh, I'm going to introduce the warp space down here. No, you can't. General relativity, the equations are field equations. They're only macro equations. They're equations for the cosmic scenario. Okay, please understand that. Here on Earth, like if you're going to explain the Cavendish torsion balance experiment, which is what they use to determine the gravitational constant G in a lab. You got your little lab. You put your little hair holding a little bar, and you have two weights. That's essentially what the torsion balance is. And you put two masses, two big heavy things on either side, and you'll see that that thing slowly moves towards these two objects. Okay, that's the torsion balance. And then all you have to do is calculate, the how much the string torqued, and gives you the gravitational constant G. But the point is, you can't say, "Oh, I know what happened. Space is warped down here. In that little space is warped." No, no. If you want to warp space, you need the sun. You need to put the sun in that space, or maybe a black hole. If a little tiny black hole, smaller. The event horizon so big, maybe you would need a micro black hole, and nobody claims that. No, general relativity is for out there, for cosmic stuff. If you bring it down here, people are just going to laugh at you, the mathematicians. I'm not talking about me. I'm going to laugh with them. Unfortunately, I have to be on their side on this, okay? So just be aware. You can't use general relativity here on Earth. Okay, so what does all this take us to? It takes us to the golden principle, okay? Golden principle, that's the first principle we have in physics, and that's physics requires an object. You can't do physics without an object. First question a physicist must ask is, what is an object? What is an object for the purposes of physics? And an object, somehow I got lost on my definition there. The definition is that which has shape. And those are the synonyms: thing, anything, something, etc. That which has shape. That's what an object is for the purposes of physics. It's the only property that all objects have in common. And if you know of any object that does not have shape, please get in touch with me. Okay, I'm really curious to see which object in the universe, which word in the dictionary which represents an object does not have shape. It's the only property all objects in the universe have. It's a universal property of objects. No concept has shape. Okay? So anything that has shape, we're going to call an object, whether it exists or not, which existence is a separate issue. And people don't understand that. They confuse existence with object. Object, that which has shape. Existence, an object that has location. And that's a long story. but it's the word exists is very different than the word object. Object stands alone, and that's only that which has shape. Well, so once we have all that, I can now address some of the other comments that I found in the videos that I posted on ether and on infinity and on space, nothingness, etc. And here's the first one. Someone, I think it was a lady, but I'm not sure, put a comment, says, yes, ether is just a whole lot of particles. Ether equals space. And so we're saying that space is equal to particles. Fine. Okay. And so now we get into the nitty gritty. The first part that I had a problem with it says the units of the ether are units of volumetric flow. And it's got something, meters cubed per second. So we're talking about flow and we're talking about per second. How can there be units of ether if ether is a bunch of particles? What does one thing have to do with another? There is no relationship here. This person is completely confused on the difference between objects, nouns, and verbs. If ether is a whole bunch of particles, that's it. Just give me the snapshot. Just show me the picture. Don't tell me that it's a volumetric flow, because a flow is a verb and a particle is an object. Okay, so you can't confuse that. And it only gets worse because it says there is only one and one ether, but there are three ether modalities. What the hell? there's only one ether, but three modalities. Okay, let's look at those modalities. It says primary ether is the white between the red dots, and the red dots are the secondary ether. Okay, fine. Tertiary ether are atoms. Well, obviously, it's talking about three different objects. We're not talking about verbs. We're not talking about flow. We're not talking about something per second. No, we're talking about pointing to an object. And this person is saying, look, the white stuff, I took one of the balls there so you can see it better. The white stuff is the primary ether. Okay, that's the one we're concerned about here. We don't care about the secondary ether because this person essentially is saying that the balls are not the same thing as space. And so the ether equals space already dies right there. We have two things there. We have the balls and we have the white stuff. And so if the ether is the balls, it can't be the white stuff. And if the ether is the white stuff, it can't be the balls. It's just like that. That's simple. Okay, so you can't have it both ways. And let alone the tertiary one where it's something else, the atoms, which has nothing to do with either the particles that are part of the ether or the white stuff. And the question that we were trying to answer is whether either the balls are infinite, in other words, are there infinite number of balls in the universe, or whether the white stuff is infinite. Does it extend forever, whatever that white stuff is? Does it extend, and how far does it extend? Is it infinite? That's what the Greeks were trying to determine. That's what we've been covering in the last 2 weeks. And so if we take it one more step, just so this person understands, okay, here I made a little diagram. Here's the ball, okay, the secondary ether. It's surrounded by the white stuff, which was, according to this person, a primary ether. Okay, that's what we had so far. Okay, and so I'm saying, what does X, the primary ether, how far does that extend? Is that infinite? And the person has two choices. You can say that the white stuff extends infinitely, unboundedly, to wherever the eyesight reaches and beyond. It's indefinite, or is it contoured by Y? And if it's contoured by Y, what is the Y? Is that a medium? Does that extend infinitely or indefinitely or whatever? And the person said, well, it's contoured by Z. Well, at some point you got to stop, because an object is that which has shape. And X has shape, Y has shape, Z has shape. The black stuff does not have shape. The black stuff just extends, and you got to tell me what that black stuff is. You can't elude the question. You can't continue saying, well, Z is contoured by double A and double B's and double C's. You can't continue that forever. At some point, the buck stops there. You got to stop, and you got to identify what encompasses it all, what encapsulates it all. Okay? So this is the problem. The problem is that this individual who is believing that he or she answered the question has only eluded the question. The question we have to answer is the primary ether, the white stuff there, the X, is that infinite? Okay? And if it's infinite, that means it extends forever, and that opens up, a big can of worms because, we got to figure out what infinity means. Is there something that is infinite? Okay? And again, most of you know my version of that. Space is nothing, and nothing cannot be infinite because only objects can be qualified with adjectives. Infinite is an object, it is an adjective, just like finite is an adjective. And you can't call in physics, you can't call an object infinite because all objects are finite because an object is that which has shape. So you cannot say there's an infinite object because what you're saying is that there is an infinite finite. It's an oxymoron. It's a contradiction in terms. The word infinite is an irrational term, an irrational adjective for the purposes of physics. In ordinary speech, you can say infinite love if you want. I don't care. In science, in physics, you cannot say that an object is infinite. So if space is an object, it cannot be infinite. It's either an object or it is infinite. And there is no such thing as an infinite object because all objects, by definition, have shape. The only property all objects universally have. That's the rationality behind it. So what does that leave space? Space is nothing, and nothing is a concept, and concepts cannot be infinite. Nothing is the opposite of something. If something is that which has shape, nothing is that which doesn't have shape. Okay? That's the logic for the definitions. Once we have those definitions in place, we can use them consistently, rationally, scientifically. Okay? I hope you follow my train of thought. Okay, here's another fellow, and I think it's a fellow, and he said something like, and I'll just go through the red parts. Undetectable at our scale. In science, we do not detect anything. We don't care about detecting. We don't use our hands in science. Transfer of information, we don't transfer concepts. So that's okay in ordinary speech. It's okay in irrationality or in religion, not in physics. In physics, you cannot transfer information. You cannot transfer energy. You cannot transfer mass. You cannot transfer time. You cannot transfer concepts, period. Cannot be measured. In science, we don't measure anything. Measurement is what mathematicians do. In science, we do not measure. In science, we explain. What was the definition of science? Rational explanation. We're going to apply that definition strictly, rigorously to anyone who brings any other word that's not rational explanation. Okay, so you can go and challenge the rational explanation definition, but you cannot say, oh, yeah, I agree, rational explanations, and then talk about transferring information and doing measurements and detecting. Here it says, directly interact with and manipulate. Again, we don't interact. We don't have to interact with anything or manipulate. Next one, he says, all we can do is poke at the adjacent fractal and watch. In science, we don't watch, we don't observe, we don't gawk. In science, we explain. We don't have the technology. We don't care if we have the technology because we have no use for technology in science. In science, all we do is explain. We don't do predictions. We don't interact or manipulate objects. And we don't care about if it's currently beyond our technology. We don't do predictions. It's astrologers who do predictions. In science, we only explain. And then he talks about consciousness, and that's completely outside the bounds. He's introducing now philosophy and what people believe. He's introducing observers. What I believe, what I think I saw, when I was drunk, I don't care about all that. That's not physics. In physics, we don't care what you saw, what you testified to. This is not a court of law. Law is religion. Law is religion because the prosecutor and the defense attorney are trying to convince the jury. They're trying to persuade. They're trying to win a case. That's religion. That's got nothing to do, with physics. Physics, we only explain a mechanism. And again, you don't have to agree. All I'm saying, that's what I'm proposing. I'm proposing that science is about rational explanations. In the case of physics, rational explanations involving objects, mechanisms, causes, phenomena that occur, right? And if that's the definition, we're going to have to stay strictly within those bounds. So you can't say, well, I'm going to introduce mathematics because that's what's been traditionally called science. We don't care. We don't need mathematics to explain how the window broke or how you pulled on the, through the rope, the box through the pulley. Okay? There was another fella, I think fella, maybe it's a woman, and he was interesting because he brought in, says, first we get a model that we can use. Then we can haggle over what we cannot see after we get the working model. Absolutely not. No, no, no. Wrong, wrong, wrong. What did we say? Let's put this back up again. Where is it? Let me find it. Where is it? Here it is. The first step is the hypothesis. First step. First step. You must put the objects. You have to define exactly what object you're going to talk about and what object is going to be the main protagonist, the main actor in your theory. You cannot say, oh, I'll figure that out later, like this fella says. This guy says, oh, no, why worry about the objects? We can't see them. We can't touch them. We don't know what they look like. Let's worry about that later. Let me tell you my theory. Let me give you my explanation first. So should I introduce a spirit and say, look, I don't know what a spirit is. I've never seen it. Don't worry about that. Let me just tell you how the curtain moved. You know, the spirit of your grandmother came down and she moved the curtain. Well, hold it. Show me the spirit first. I want to see the spirit before you tell me your theory about how the curtain moved. And this is the problem with this individual. He thinks he's doing science. Then again, he says, the problem is that you are forcing anyone with a model based upon the ether into a box by requiring them to incorporate an imaginary concept into their model, such as space. Yes. And for this, I need to go back to this, where was it? Let's bring that back in there so this person understands what the problem with that is. Here we have it. Okay. Yes, I need to introduce that black stuff, which is space, because without that, all I have is nested objects. I have one object inside another object inside another object. And how far are we going to take that? Are we going to say the ether is enclosed within space? And what is space? Well, it's another object. And what is enclosed by? Well, it's enclosed by thought. And what is thought enclosed by? It's by the fifth dimension. I mean, how far are we going to take this? You can't just continue adding ad hoc things just to get away from the question. And this is the problem that this person has. He wants to avoid the real question, and the real question is what encapsulates it all. So he doesn't want to deal with that because he doesn't know. He doesn't have any idea. He says, now let me tell you my theory. We'll worry about the objects later. That's what he's saying. And then he says we will be unable to see anything. Again, blind men can be physicists, scientists. We don't need to see anything. A scientist can explain a theory to you. That's all he needs to do. He doesn't need to touch anything. He doesn't need to see anything. He doesn't need to see a black hole for sure because allegedly no one can see one, right? So we don't need to see light. What is light? All we need is the theory. We need to explain how light does its tricks. Define the ether by what we can observe it doing. No, absolutely not. That is called an operational or functional definition. And those belong to religion. They're totally irrational. Operational and functional definitions, someone who's lazy and could not define the term on his blackboard. He comes to the conference and says, let me tell you what an object is. And he goes through this whole thing and says, what is blue and what runs and jumps and what does this and what does that. And then he finally says, see, I was talking about, a blue extraterrestrial. That's not the way it works. You got to present the extraterrestrial at the beginning of your dissertation And then you can describe him. You can say he's blue, he's green, he's whatever. You can tell me anything you want. But this guy wants to do it in reverse. He says, I'm going to give you a functional or an operational definition. I'm going to say, look, we don't know what this ether stuff is. We're just going to define it by what effects it has on the real world, on real matter. Well, that's how they discovered the black hole. They said, look, we don't know what a black hole is, and they still don't know. In fact, I just recently wrote an article on Quora about that. We don't know what a black hole is. Don't worry about it. Let me tell you how it affects the star over there. So he says, look, there's this invisible zero-dimensional nothing, but it's got lots of mass, and it's affecting this star far away. It's forcing it to go around in circles. Well, I can just say, similarly, I can say, well, why don't we just put a spirit? We don't need that. We can just do it with magic, right? Just put a spirit with a magic wand, and that spirit just waves the wand around, and the star goes around. Now, there's a mechanism for you, right? I mean, how's that different from this guy saying there's a zero-dimensional volume singularity, and that it has the ability to move a star around itself? Okay? You see the problem? And so this is the problem. The issue is that these people are trying to avoid the object. I need to have an object there, and they have to get rid of the objects and just deal with math. They say, well, no, we don't have an object. What we have is lots of mass. See, and this is what this individual is trying to do. He's trying to avoid the objects, and that's why objects are so important in physics. And the last one, he says, next to the last one there, we know sound can travel in the same way as light, and air is not a solid, so we can get light propagation without the ether being a solid. It can be a gaseous fluid. If we look at the ether as a fluid, as Tesla said, it is the magnetic field we see flowing everywhere. We get a good model for the things that we see ether doing. So again, he's trying to figure out what the ether is, or maybe not even interested in that. He's just saying, let me just tell you what's causing this. What's causing is something called the ether, but let's not worry about that. Let me tell you why this thing is moving. It's moving because of the ether. But see, he makes a lot of errors there, and the main one is this one, that I don't know how to convince him, but I guess he's going to believe whatever he wants to believe. But transverse waves cannot move through ether, and that's the point that I was going to make today with the continuation of the 19th century version of ether and transverse waves discovered by, introduced by Mr. Fresnel, Augustin Fresnel. And the problem that they had, the big problem, was that transverse waves cannot move through the body of water. They cannot move through, undercurrents. Cannot move under the ocean. It can move above the ocean, yes, not in the ocean. So whoever said that needs to learn a lot of stuff. And here it is. Let's wait for it to start there. You got the currents, you got the waves. Currents go underwater. You cannot have a transverse wave move through the inside of the body of the water. No way, no how. So he's got to learn a lot before he can post this type of stuff. Transverse waves do not move in the body of any liquid, any fluid, or in any gas. So, I don't know. If he wants to continue believing that, fine. He can make that assumption. It's simply not true. It violates our experience. We've had enough experience to know that transverse waves cannot operate. I mean, I challenge it to go ahead and show me a transverse wave operating in gas or fluid. And you can look it up. I mean, you don't have to take my word for it. Look it up. Just every experience out there, everybody will tell you transverse waves don't move through fluids or gases. Okay, transverse waves only propagate through solids and beyond. Like I said, you can't even transfer transverse waves through something made of a single piece. You can't do that because single piece has no vibrating particles, no units or whatever that make it up. It's a single piece. But if you have a steel beam, yes, you can send transverse waves through there. You cannot send it through water. You cannot send it through gas, through air. Okay, and some people will continue to believe that, fine. So Tesla was wrong. Tesla had no idea. Besides, he lost his trial against Marconi uh, back in, what was it, 1904. The Supreme Court ruled against Tesla, who was an engineer. He was not a scientist. He had no idea what science was. Tesla came up with a radio, and he was gypped in many ways because Tesla, I think, did invent critical pieces of what was going to become the radio, different thoughts, right? And Marconi kind of took a lot of that away from him. He was a richer guy, had more money, had more influence. And it turns out that, Marconi gets the Nobel Prize in 1909, gets the Nobel Prize for inventing the radio. And then that was taken back from Marconi. The Supreme Court ruled sometime in the 30s that Marconi was not entitled to all those patents. And the only reason for that was also political, had nothing to do with science. It turns out that Marconi sued the government saying, hey, World War One, we thanks to us that we invented the radio, you were able to do all these good things. And the government said, well, we would love to pay you, but see, you're not the owner of all those patents because all these other guys, especially Mr. Tesla, he came up with that first. Well, Tesla was dead by that time, so he never got to know about that. So, yeah, Tesla was not a scientist. And anyone who considers Tesla a scientist simply doesn't know what science is about. Tesla was an engineer, and he worked originally for Edison. Took some of those secrets because he was a bright guy for inventing stuff, and he developed the radio, some of the concepts, especially the Tesla coil. And so he came up with these ideas. You got to give him credit for that. Nobody did. He died poor, died in, I think, in a hotel uh, room or something. Anyways, he died penniless. And only some people remember him, today. And again, they follow Tesla because they're mainly against the establishment, quantum mechanics and general relativity. They hate all this stuff about space time and black holes. But not because of that you're going to embrace, a guy like Tesla. He had no clue. Tesla had some good criticisms of, the establishment. He did good criticism, but he had nothing to offer in exchange. Anyways, I'm going to continue with what happened in the 19th century, which was I was supposed to cover today. I'm going to continue with that on Sunday. And I'll see you all then. Bye-bye.